Alright, so you're going to look at this and determine which hill would you rather climb and why. So take 5 to 10 seconds, look at that. Go ahead.
The one on the right, because the slope isn't really steep.
Okay, so it doesn't have a steep slope. Anyone else?
The view's better on the right.
What if the view was better on the left?
It's not.
But what if it was?
Still the right.
Okay. So for a better view, the slope, the steepness. Anyone else? What do you say?
I say the one on the left because no pain, no gain.
Okay. So you'd rather take that experience and then gain muscle experience, all those things. Ace?
The one on the left because there's support to help you get the...
What if there were the same amount of people on this hill?
Oh, I was talking about the rope. There's a rope
Okay.
on it to help you get up there.
What about the same thing here? What if those were here?
I mean, I guess.
Okay. Go ahead, Robert.
The one on the right.
Why?
I have less of a chance of falling off.
Okay, fair. Because of the steepness, because of the slope.
Either.
What if you had to choose one?
I just jump off the cliff.
Okay, let's not do that. Anyone else? I would probably do this one just because I'm not that much in shape. I don't do a whole lot of exercise like that. So this would be challenging for me. Going up the stairs a lot is a lot for me. So this would be a lot for me. But be thinking about those reasons and all of those for later. Look at your course calendar. I need to have one of these so I can talk about it. So as we kind of talked about Unit 1, it was short. We didn't have a test for it. We will be coming back to it using those different things in the data cycle, formulating questions, collecting data, organizing and representing data, and analyzing and communicating the results. We'll be doing that throughout the year in different aspects. But we're going to move on to Unit 2, which we're starting today. This is like a test run, kind of, because the standards change. So we may not get through everything I have planned. These are always tentative, so it's okay. We'll just move whatever we didn't do onto the next day and so on and so forth. So I'm really just trying to gauge where we are with this stuff. Time-wise, how much we get through. We do still have to get through all of it. The quiz at the bottom may or may not be a quiz. So it will definitely be some sort of review. It will either be a review of some sort, or it will be a review quiz. It really depends on how much we get through and how much time we have up to that point. You will have a test on it, which means you will have some sort of review before that. There are different Delta Math. There is a Desmos activity on there too. Some are formative, some are informative, so make sure you know which ones affect your grade, which ones don't. I'm not saying don't do the ones that don't affect your grade, because it's still good practice for your tests. And you still need to know that stuff, and it will still be missing, even though it's not affecting your grade, so keep that in mind. Do we have any questions about the calendar? I said this to all the classes yesterday that I was going to put it on Canvas, and then I forgot. I'm going to do that today. I'm going to write myself a note, so I do it today. Okay. Note. Alright. So with that being said, we're going to go ahead and start notes. So everyone should have notes. The white kind of notes. We're going to take some notes. If you need to move around to see a little bit better, do that. If you need me to go back to anything, if you need highlighters, grab whatever it is you need to help you be successful to take these notes. You want to flip forward instead? Alright, so a lot of the stuff that we're going to cover in this unit, some of it will be reviewed, and then some of it will be new. Go ahead, Mom. So if you find something that, like, oh, I remember doing this last year, good. We need that knowledge, that prior knowledge, but we're also going to cover some new aspects to it as well. Alright, so let's talk about slope. First, you're going to see this learning target. I wrote it, so it's kind of messy, but it is clear over there under the objectives on the board. But you'll see this on a few of the things that we do, just because we have to cover a lot of things: domain, range, zero, slope, and intercepts, all of those things, so you'll see that a lot. But first, we're going to cover slope, because that'll kind of help us build with some of the other stuff. So with our slope, you need to remember a couple things. One, that we use the letter M to represent slope. And with that M, it represents the change in the y value over the change in the x value, or the change in the dependent variables over the change in the independent variables. Also known as the vertical change over the horizontal change. Also known as rise over run. So you may have heard one of those things. You may or may not have heard this one. This is also known as the constant blank of blank between points on a line. So you'll know that one. So that one's rate of change. So if you hear any of those words, rise over run, slope, vertical change over horizontal change, rate of change, they're all interchangeable. So don't get confused by that changing in wording. And then we're going to find our slope by counting. So I'm going to visually show how I'm counting. You don't need to do that. You can just count it. But because we're doing the rise or the vertical change, I have to count up or down first. It does not matter, and I'll explain that in 1 second. But let's say I'm starting at this point over here. I'm going to go straight up to count my rise. I'm going to count 1, 2, 3, 4, 5, 6. Going up 6. That's going to be important for something I'm going to talk about. And then I have to find that other point by finding my run, or my horizontal change. 2, 3, 4, 5, 6. So I'd be going up 6 to the right 6, which would be some 6 over 6, which would simplify to be what? 1. After we finish this problem, I forgot to tell you to get your calculators because you'll need them. So after we finish this, you can grab them. All whole numbers, so think of all the whole numbers that you know in your life, are really fractions. So I could really say this is really 1 over 1. The ones are invisible. The denominators are invisible. So if this is my rise over run, I could say that every time I go up 1 and over 1, there should be another point on this line. So to test that, if I start at this one and I go up 1 and over 1, there's another point. Up 1, over 1, and I keep doing that, and there's a point at every single up 1, over 1, all the way up the line. Right? Let me finish this. Okay. So I said that the order doesn't matter if you go up or down first. It depends on which point you start at. So let's say instead of this point, I started at this point instead. I still have to do my rise first, which is still up or down. But in this case, I have to go down. And then over to the left, 6. Yes. Right, so this would make this negative. This would also make this negative. Down and left are negative directions in general. But if I have a negative over a negative, they cancel each other out. It's still positive. So you can go either direction and get the same thing. Questions on that? Okay, go ahead and go get your calculators. Alright, so we're going to count the slope for number 2. So I heard -3 going down 3 and to the right 6. But we can simplify that. 3 over 6 would be 1/2. And because the 3 we went down, that would be a -1/2. Which means every time I go down 1 to the right 2, there should be another point. But if we went the opposite way, so let's say we started at this one instead, and I went up 1 and to the left 2. We're still going to get the same answer. However, you may want to write it like this. And this, here's maybe what you were talking about. You won't see this negative in the denominator ever. So if you get something like this, even though the negative went with the 2, you won't write it like that. You'll either write it like this, or you'll put it out front. So one of these two, but not this. Okay, questions on that? Who remembers finding slope from a graph? That should be a lot of us. Good, good. All right, let's do the next one. Go ahead and find the slope of this. What is that slope? 7 over 2 is what we should have gotten. Okay. So now we're going to start to build how we do this algebraically. Some of you may know that already, and great. What are the y values of these coordinates? We can say it, then out loud.
4 and -3.
4 and -3. I'm going to write it in least to greatest, -3 and then 4. And then in general, what do these y values represent with slope?
How high the point is.
Okay, how high the point is, or if you're looking at the top, what the different names for slope?
The rise.
The rise, there we go. Also known as the vertical change, how high the points are going. So if we wanted to use these y values to get part of the slope, so think about, we're looking at the vertical change, how could we find that distance? It does give you a hint. Think about adding, subtracting. Do we do something with those two numbers to get that distance? You said two different things. You said divide. How would we divide them? You were going to say the top and the bottom. How would that measure our distance? How would that get us the distance we want between us? Think about that. What did you say?
Oh, I said
Okay, we will simplify in there somewhere. What math operation? This is not going to be divided. If we added this and this together, is that going to help us with our distance? Multiplying would probably be too much, but subtracting. And then we kind of want to think about how we would subtract this. This doesn't have to be an immediate answer, but if I'm looking for the distance between these points, would I subtract, like, from here to here, or from here to here? How exactly would I do that? Be thinking about that, we'll come back to it. What are the x values of the coordinates? 3 and 5. It is 5, yep. And then what do the x values represent? The run or the horizontal change. if we subtracted for the y values, we're going to do the same thing for the x values. And now we're going to talk about that how. Did anyone have an idea how we could subtract these values to get that distance? If I like jumped up in the air and I wanted to measure that distance, would I go start minus where I jumped up or where I jumped up minus the start? So like the end minus the beginning. I'm just gonna start. And then for our x values, it's not a vertical distance, it's a horizontal distance, but you're kind of thinking the same thing. We could kind of word it the same also. That end minus the start. You just have to know in your mind which one is the end, which one is the start. So for our y values, which number would be the end? So which of these two y values would be that end? The 4. So usually the higher one, the top one, would be that end. And then for our x values, which one would be the end? 5. So usually the one furthest to the right. So then we're going to test this here on the next page. So once you have that, go ahead and go to the next page. Have this on the flip 2 pages, but sorry, I meant 2 pages. So the back of this is just more practice if you would like more practice to find slope from a graph. Later at home, whenever you have that. But find a page that looks like this. So then using the 2 things we just talked about, subtracting the end minus start, kind of for both, we want to come up with a general rule for finding slope. We know our slope is rise over run. So we're going to kind of put what we had together. And I'm going to use the specific top minus bottom. Top y minus bottom y over right x minus left x. And then we're going to test this and see, does it work? So the top y of this graph would be what? Is that your y value?
It's 3.
It is 3. What is the bottom y? Negative 3. So notice that I'm going to put minus a negative 3. We're putting both. The negatives will come together, make a plus, but we'll do that in 1 second. And then the right x, or the right furthest to the x furthest to the right, I said that backwards. Negative 2. And then the left x, negative 5. So again, I'm going to put in parentheses that minus 5, that negative 5. And then you could either do this part in your head or you could use a calculator. So in your head or algebraically, know that the negative and the minus come together and make a plus. So this is really going to be 3 plus 3 and negative 2 plus 5. If you would like to do it in the calculator, you just need to know that this sign at the bottom is a negative. So whatever you put in, these are still your regular signs, but this sign is a negative. So you put it in as 3 minus a negative, like that. And you should be able to see the difference because one's longer, one's shorter, one's higher, one's middle. What do we get here? 6 over 3, which simplifies to close, other way. 2. 2 over 1, or just 2. Which means if I go up 2 over 1, I should end up at a point on this line. Which I do. And keep doing that just to double check it. So yes, you are correct. And the slope was 2 on the graph as well. So if you ever forget the actual formula that's after that, you can always go back to that. Remember that. That's top y minus bottom y, right x minus left x. But this is the actual formula. Very similar, but now with y's and x's, not with all the words. And we're going to do this for a couple problems. Before we do that, though, because we'll need this, take a number, your favorite number, whatever number you want, put that in the calculator, and then divide by 0. And tell me what happens. You should get an error. You cannot divide by 0 in this class. When you go on to calculus and stuff like that, you can divide by 0 in there, but not in algebra 1. And that's going to help us with something we need a little later. So let's go ahead and find the slope of these points. I'm going to use the formula. I'm going to label these x1, y1, x2, y2. If that helps you do that, if you're good without it, you don't need to do that. That's it. Okay. And then I'm going to go ahead and put them in that format. So m equals my y2, 8, minus my y1, 7, all over my x2, negative 4, minus my x1, negative 2. And then I want you to go ahead and find that slope. So we should have gotten negative 1/2. If you're trying to remember the formula instead of the words, which is fine, let's say you happen to switch these, you forget the order and you put y1 minus y2 instead, that's fine, as long as you also switch the denominator too. So if you switch one but not the other, you're going to get a negative when you should have got a positive, or vice versa. But if you switch them both, it doesn't matter. So just keep that in mind. All right, any questions on this? Who has done slope with the formula before? A couple of us, and you not as many. Okay. Some teachers get to it, some don't. All right, let's do it again in number 8. So again, I'm going to label. If you don't need it, you don't need to do it. And then go ahead and put those into the format, into the formula. 15 minus 5 over 6 minus 4. What would that slope be? Say again. 10 over 2, which would be 5 over 1, or just 5. So when you can simplify it as much as possible, but leave whole numbers as whole numbers. Questions there? Yes. So here in this, I'm following this. So since this is y2, I put that right where that goes. And since this is y1, I put that right where that goes. Same thing. So since this is x2, I put that right there. And then since this is x1, I put that right there.
Are you putting that as y2 because it comes second, or because the numbers are bigger?
Yeah, just because it comes second. So I just said this was 1 and this was 2, but if you switch them, let's do that really quickly. If I switch them and did 5 minus 15 and 4 minus 6, you get negative 10 over negative 2, we're still positive 5. So it wouldn't matter. Okay. Other questions? You don't need to write this part, I was just showing you an example. Alright, now go ahead and plot these points on your graph. And we're going to, again, find the slope using the formula. So we have y2, 5, minus y1, also 5, over x2, 3, minus x1, negative 4. What happens there? What do you say, Michelle? We get 0 over 7. And 0 divided by anything is what? 0. The way these points look, is that look more like a vertical line or a horizontal line? Horizontal. It should be a horizontal line. That was not straight. Attempt to make a straight horizontal line, not crooked like mine was. And then go on to the next page. I can't extend, so before this updated, I could extend this and make this go up higher so those in the back could see, but now I can't. So feel free to look at the other board if you need to. Okay. This one kind of gives us the answer already because it's saying something about dividing by 0. But go ahead and plot the points. And then I'll set up the slope formula really quickly. And when you get something like this, anytime you see 0 in that denominator, you have to know that that is going to be an undefined slope, or UND. Are these points making a vertical or horizontal line? Vertical. So attempt to make a straight vertical line. Oh, that would. And then, based on the two problems we just did, what can you conclude about the slope of all horizontal lines? Yes, they're going to be 0. And I want you to write this, H-O-Y. And that is going to stand for or represent horizontal lines have 0 slope, and you don't really need this part right now, but it'll come in handy later, is y-equals. So horizontal lines have 0 slope and are y-equals. And then what could we conclude about the slope of all vertical lines?
They'll be undefined.
They'll also be undefined, or they'll be undefined, similar to this one with 0. And then I want you to write VUX. And that'll kind of be the opposite of what we just wrote. Vertical lines have undefined slope and are x this will come back all throughout the year. So if I say koi bucks, I'm talking about this, not koi's in Spanish. To represent our horizontal and vertical lines. Okay, I'm going to give you 1 to 2 minutes to try one of these problems. I'll be walking around if you need my help or need me to check anything. If you finish that problem before I come back up here to bring us all back together, you can start a second one or start a third one, depending on how fast you work. Okay, let's come back together. Were there any of those problems we wanted to see, go over, have questions about? On the next page is more practice problems of finding slope from 2 points. Again, we're going to skip that for now. And go on to the last page. So, we've talked about slope from a graph, slope from 2 points. Something else we kind of need to talk about in order to get to the next thing is this. So look at this table, and what do you notice about how did they find the slope and y-intercept? How did they know that this number was the slope? Where did they find that out? Okay, so it's right next to the x. Is that same pattern follow for each of these? Yes, so we can say the slope is right in front of the x. And the y-intercept is the last number. So if that's the case, then what is the slope in this equation? 2. And what is the y-intercept? 3. So now we're going to test that theory to make sure the slope is indeed 2 and the y-intercept is indeed 3 by using this table. And you could do this for any equation, any graph. So we have this table where we're given some inputs, some x values, independent variables. You can pick these at random. I would say pick some negatives, pick some positives, put 0 in there. Doesn't have to be 6, it could be 5, but you need at least some negatives, some positives, and the 0. We're going to put these values in for x, input them into x. And we want to get away from using like the dots, the x's for multiplication, and use parentheses instead. So I'm going to write this as 2 parentheses negative 3 plus 3. And then we want to figure out what that is to get the output, or the y value, that dependent variable. So 2 times negative 3 would give us negative 6. And negative 6 plus 3 would give us negative 3. Thank you. So I could put that input and that output together in this order pair, negative 3, negative 3. And then plot that point. So if you feel like you got it and want to keep going, go ahead. I'm going to keep filling out the table. I'm going to go column by column. So I'm going to fill this out, just changing what's inside the parentheses to whatever the input is. So 2 times negative 2 plus 3, 2 times negative 1 plus 3, 2 times 0 plus 3, 2 times 1 plus 3, and then 2 times 2 plus 3. And then I'm going to start to find the output by multiplying the first two together. So we have negative 4 plus 3, negative 2 plus 3, 2 plus 3. Oops, sorry, that should be 0. Then 2 plus 3, then 4 plus 0. To get negative 1, positive 1, 3, 5, 7. And then I'm going to put the x and the y together as ordered pairs. So -2, -1, -1, 1, 0, 3, 1, 5, and 2, 7. And then I'm going to plot the rest of those points. So based on our graph, what is the y-intercept? In this case, it's talking about where does it cross the y-axis at 3. And I'm going to write it as the ordered pair that we have, 0, 3. And then using the graph, what is our slope? No other way. 2 over 1, because we're going rise and then run. Which we knew that already because of looking at the equation, we found that. But now we just found it a different way from the graph. Now, we picked random x value. I really picked them. And then we put them in and solved it. But how do we know that these are the actual points that fall on this line? How do we know that we didn't do that math wrong? So, one way to check yourself, to test this, to make sure you didn't actually, like this part, you can't really mess up. But between this, it's very easy to miss a negative, to put the wrong thing, and get a wrong point. Now, usually that will end up, your line won't look like a line, and that will tell you something's off. But it may be, maybe the line looks okay, and you're not sure if there's something off. So we're going to pick 3 of these ordered pairs and we're going to test it out. Which 3 ordered pairs do we want to test? You guys choose. We want to pick one of these? Doesn't matter. Okay. 1, 5, 2, 7. Alright. So I have to go to the next page because I can't do this down here, but you should have enough space to do this down here. So -3, 3, 1, 5, 2, 7. I'm going to erase that. Good. Okay. I forgot. -3, 3. Okay. What was the next one?
-1, 5,
1, 5, and 2, 7. Alright, so to test this, to make sure these points actually fall on this line, I'm going to take the equation that we were given. These are my input and output values, and I'm going to put them into where x and y are. So this would be -3 equals 2 times -3 plus 3. And then I'm going to see, does this work? Does it make a true statement, true equation? So here we have -6. -6 plus 3 is -3. This matches. So I know this is a true statement, this is a true equation, this is an actual point that falls on this line. If you got 2 different numbers, something went wrong, and either this point is not on the line or your math went wrong. One of the 2. I'm going to quickly do the other 2. So for 1, 5, I put in 1 and 5. 2 times 1 we know is 2. And 2 plus 3 is 5, so that works. That is a point that falls on the line. And then for the last one, 2 times 2 is 4. 4 plus 3 is 7. So I know that is a point that falls on the line. So anytime you're not sure, use this method as a way to check yourself. Do you have any questions on that? Right, last page. This one will go faster. And then you'll have a chance to explore. This is probably the most notes we'll take this entire unit. This one just had a lot of vocab and things we needed to catch up on. A lot of the other stuff will be kind of given to you. Okay, so the table thing that we just did is to let you know that each point on the graph on a linear equation in 2 variables is a solution. That's why it equaled itself at the end. It makes it that true statement, that true equation. So if it works, then you know it's a point. If it doesn't work, then it's not a point. This slope-intercept form is going to be really important. We'll come back to it. Use it a lot. Use it often. What does M stand for? Slope. Good. And then what do we think the B stands for? Point. Yes. Which is why it's called slope-intercept form. Right? So we kind of did this earlier. We're going to just do it again. What is the slope of part A? -2, and then the y-intercept is 1. What about for part B? What is the slope? Be careful. Is that one in front of the x? It should be 3 over 4. So they switched the order to be careful because that happens sometimes. So that means the y-intercept is -7 over 6. The slope for part C, 5. What about the y-intercept? It is 0. So if there's nothing there, assume it to be 0. Right? The rest is just kind of more of what we already did. How do we feel about finding slope and all of these things? Good, okay, not good? Show me with your hand. So good, up, thumbs up, okay, I need more practice. Sideways, not good, I don't understand what we're doing at all. Thumbs down.
Is there a difference between the y-intercept form and the slope-intercept? Like the one that's on this page?
So those were in slope-intercept form. We just hadn't introduced that word yet.
Oh.
Okay? Robert? Yes. Alright, so now we're going to get a chance to explore and talk with each other. We're going to be using slope, but not to the extent that we were just doing. We're going to do something else. So I'm going to have you do this first, and then I'm going to pass out the thing and then explain that. So on your iPads, make sure you're logged into your Canvas. Actually, that part doesn't really matter, but you can log into your Canvas. And we're going to stay on the home page, so don't click anything yet. So once you're in Canvas on the home page, you're gonna you may have to scroll, you may not have to scroll. Click on the Unit 2 course unit. Once slide loads. There we go. you're gonna go into lesson 1B, where it says transformations. But you're gonna go to the transformation notes. So unit 2, lesson 1B, transformation notes. Go into that. And then you may have to scroll, you may not have to scroll, but you're gonna click on the Desmos expiration after I unlock your iPads. Because it won't work unless I do that. So once that unlocks, you should be able to click. If you're not sure where that was or you got lost, raise your hand, I'll be around in 1 second. I'm going to pass out. You guys are going to do this by groups. Everyone sitting at your table is your group. And you're going to follow these directions. So you're already at the link. You don't need to go anywhere because this takes you directly to it. But then you need to follow these directions. No one person should be answering all the questions. You guys are doing this together. I'm going to have to pass 2 of those back. Yes. Yes. It's like right this one.